Good morning and welcome back to another show of some random show. Sorry I couldn't think of a name in time. So, the electromagnetic spectrum. It's a continuous spectrum of waves. Waves. It's clearly the most interesting thing you've ever heard of. It's kind of as interesting as this plank of wood, for example. And so I kind of understand that you are probably not very interested right now. And so I promise you, you have my word, that at the end of this episode, if you can make it through, I will show you a video featuring teacup things. And that's just too cute to miss. I promise you, I will show you that. So, the electromagnetic spectrum. At one end, the waves are very long in wavelength, and this has very low frequency, kind of like Chris's voice, for example. And it's pretty good, isn't it? And at the other end, the waves have very short wavelength. This makes them very high frequencies, so like Ramise's voice, for example, if you know who he is, or remember him, or if you forgot him, it's fine, he's Ramise. But don't take it from me. Listen to what this lady with an American accent has to say.
Electromagnetic radiation travels in waves. Frequency describes how many waves per second a wavelength produces. Wavelength measures the length of an individual wave in meters. Scientists describe the electromagnetic spectrum as a long line. At one end lie radio waves, with the longest wavelengths and lowest frequencies in the spectrum. A single radio wave has the length of a football field.
Okay, I'd just like to point out that when she refers to football field size, she is referring to this, which is a barbaric, weird sport that Americans play. Just look at the guy in the middle. It's just the saddest thing you'll ever see on TV. And this is real football. This is what people with brains play. So let's talk about the different types of waves. So, we have radio waves, which is used for broadcasting things like communications and things like that. Microwaves are used for cooking horrible food. Infrared, used in night vision. Visible light, this is what we see, so obviously photography. And ultraviolet, used in fluorescent labs, those really weird lights that they seem to use everywhere. Don't understand why. X-rays, used in X-rays, I guess, because it's kind of in the name. And gamma rays are used for sterilizing food and medical equipment. Okay, so you may want to remember it like this. Rabbits mate in very unusual X-rated games. The amazing thing is that all of these waves travel at the same speed. Yes, that's 300 million. Is it 300 million? Is it 300,000
million?
That's 300 million meters per second in free space. So let's refer back to that American video to talk you through visible light.
Spectrum nestled between infrared and ultraviolet light. Red wavelengths have the lowest frequencies and longest wavelengths of visible light. As you move from red through orange, yellow, green, blue, and finally violet, wavelengths shorten and frequencies increase.
Okay, now some of the more eagle-eyed viewers may have realized that that video missed out indigo. I am mentioning this now because indigo, as you see here, is a color that deserves recognition. So I placed a picture for you to see, and we are going to leave it there for a while, so indigo may get the recognition it deserves. Indigo. Is that on?
I think so.
We've seen indigo.
Yeah.
Okay, so indigo. It's a long time. Yes, I can tell you that a lot of these waves on the electromagnetic spectrum are dangerous and they're strange, weird things. They can cause problems. But don't take it from me. Listen to what this credible scientist has to say.
Hi, I'm your credible scientist today. I'll be recalling some effects that waves have on the human body that can be quite detrimental. Okay, first of all, microwaves. Microwaves produce internal heating of body tissue which is microwaves producing thermal heating of body tissues, which means the person gets hot and things can burn. Infrared radiation produces skin burns. Ultraviolet radiation can damage surface cells and cause blindness. And gamma rays, these are bad. They can cause cancer and mutation of cells in the body. That's it.
As you can see, this is a very scary topic. Infrared can burn you, ultraviolet could make you blind, and most shocking of all, gamma rays can mutate your cells. Yes, this is a kangaroo with the face of a lion. I'm not sure if that's true, but if it was, it would be pretty cool. Because just imagine, the thing is, like, say you've got a kangaroo that bounces around, and it's got like a lion's mouth. It can like bounce onto prey. What do you think?
Nah.
Pretty good, like.
What the hell would I care?
No, but wait, Chris, the thing is, like, if it's like over time, so would it change your appearance over time? Would it happen like instantaneously?
Are you talking about evolution?
No, I'm talking about gamma rays, like mutation. Would that work? Never
Nah,
mind.
just move on.
It's okay. So at this point, you might be thinking, well, yes, that's very good. I know about all sorts of waves and all those stuff, but how would I make a calculation? Luckily for us, Dr. Now I've got his name here, Dr. Alistair Archibald Philbert Jeeves Bijou Bob VII is here to explain for you.
Okay, so to calculate the wavelength of this beautiful wave diagram, first what you have to do is get a duster, you put it at the top, and calculate approximately how many dusters it is across. That's how you, so we calculated, that's 7 dusters. So if you go to page 7 of the book, Prince of Darkness, the first word is tantrum. 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 That's 1, 2, 3, 4, 5, 6, 7 letters. 7 letters in the word. So what you do is 7 plus 7. Then you get the amplitude, which is y equals 3x, when x equals to smiley face, colon 3. So if you simplify this, you get rid of the colon here. So x equals 3. So when y equals 3x, y equals 3 times 3, which is clearly 2. So then you get the result of that, 14 plus 2 equals 24. Then 24 divided by, when you substitute 24 into the equation, v equals velocity times speed. V equals velocity x speed. So just cancel everything out. It's left 3 over 24, 1 over 8. 1 over 8 divided by 0 equals 73. And there's your wavelength, 73 meters per second.
Okay, so now, this was the brain break task, and as I'm obviously an A-star student, I'm going to do it. Ionization. If the number of electrons is equal to the number of protons, the atom is uncharged. This makes it neutral. However, atoms can gain or lose electrons. So this increases or decreases the negative charge. So ionization is the addition or removal of an electron to create an ion. Losing an electron creates a positive one, gaining creates a negative ion. Electrons can be lost because ionizing radiation forces the electron away from the atom. So basically, ionizing radiation can break the molecules into smaller fragments. Ions can then take part in other chemical reactions in the living cells, and as a result, ionizing radiation damages substances and materials, including those in cells of living things. This can then lead to mutations, of course. Right, so, as promised earlier, and I am a man of my word, here's a video featuring teacup pigs. Just remember, you can see them thanks to a visible light. Yes, enjoy.
They can hug the piggy. Yeah, I'm dreaming Nick.
Skeeting it. Skeeting. You're being so silly.